This is a video for AQA Further Pure Mathematics. Calculus section 1.2, we're looking at rotation about the x-axis producing volumes of revolution. Well, we saw in the last video that we could think about a volume of a revolution, the curve being rotated about an axis. Here we're showing the x-axis as the axis for the rotation. And the volume is then made up of a series of disks. The smaller the width of the disk, then the closer the actual volume gets to the volume of revolution that we're trying to find. So it's a limiting process similar to that of areas. So here we can see that we have the disk produced by the curve rotated. Now the actual disk itself has a width delta x, and the area of the disk is made up from pi r squared, where the r here is equal to the y value. So we say that the small increment of the volume, delta v, is equal to pi y squared, that's the area of the disk, multiplied by delta x. So then if we're trying to calculate the volume of revolution between x equal to a and b, then we can see that the volume will be approximately equal to the sum of all of these little volumes, so the sum from x equal to a up to x equal to b of delta v, which means that the volume is approximately equal to the sum from x equal to a up to b of pi y squared delta x. And therefore in the limit, the volume is equal to the limit of this. The limit as delta x approaches 0 of the sum from x equal to a up to b of pi y squared delta x, and that summation in the limit becomes an integral. So we get the integral pi y squared delta x, x equal to a up to x equal to b. So notice there we've got pi y squared, but we're integrating with respect to x. So just running through that again then, we've got the height of the disk being y, its width delta x, and therefore the increment of the volume delta v, pi y squared, the area, multiplied by delta x. And then the volume is a limit of all of the sums, so it gives us pi y squared dx as being the volume of revolution about the x-axis. As an example of that then, we're looking here at the volume of revolution from x equal to 2 up to 3 of the function y is equal to x cubed. So we know that the volume is given by the integral pi y squared dx, so we just simply need to substitute for y squared. Y squared will be x to the power 6, so that we get the volume is the integral from pi x to the power 6 dx. And of course we integrate x to the power 6, then we get x to the power 7, so we get 1/7 of x to the power 7 evaluated between 2 and 3. Well, that's the usual way of doing that. Substitute the value of x equal to 3 and subtract from it the value when x is equal to 2. The 7th can come out as a factor, so that we get 1/7 pi over 7, 3 to the power 7 minus 2 to the power 7. And that gives us a total value of 2059 over 7 pi. Well, that's the end of this video on rotations about the x-axis. In the next video we'll look at how we can do a similar thing, but this time rotating about the y-axis.